Good afternoon, everyone. I am here to solve the third example on charges, that is basic electricity GET 201. And the question says, what is the resultant force on Q3 in figure 5b? I know some people will be asking, what is figure 5b? This figure 5b here is just telling us the figure of this representation. In the PDF, we have three figures. We have figure A, figure B, and figure C. And this is the figure B of it. And this is the figure B as represented here. So the question is, what is the resultant force on Q3? Where is the Q3? Behold and Lord, this is the Q3. So what is the resultant force on it? First, what is a resultant force? We say a resultant force, this is a resultant force. We say a resultant force is a force that has the same effect on both magnitude and direction of two forces put together. So if you look at it, we have two forces here. We have Q1 and Q2. The Q1 and Q2, if you put them together, you have a resultant force, which is Q3. And remember, these charges, this charge is a negative charge, or this charge is a positive charge. And you know, negative charges and positive charges are unlike charges. And as you already know the law, which says like charges repel each other, and why unlike charges attract each other. This unlike charge is placed in between of the like charges, so it's going to be attracting. That's why you see the arrows are first like this. So for you to find the resultant force of this Q3, you are going to use vector nature of forces, vector nature of forces, which says F12 is equal to KE Q1 Q2 over R square vector R. All right, this vector R is just the force that is separating them. It's just the force that is separating them. So you are going to have, if following this formula, you're going to have F3 is equal to F13 plus F23. I know the question will be, what is F3? F3 here is just telling that this is the force. The F3 here is force, and is representing this Q3. While this Q1, this Q, and this Q is representing the F13 and the F23. I hope it is clear. So we are going to have vector F3 is equal to vector F13 and vector F23. Vector F23, which is equal to, remember, this whole F12 is the one that is represented here. So this motherfucker is equal to KE Q1 Q2 all over R square vector R, as you already know the formula. So how are we going to solve it simultaneously and get the answer? This is also going to remind us from the vector nature of forces, that if you have F12, this is vector F12 is equal to vector vector minus is going to be equal to minus vector F21. This is going to be equal to vector minus F21. Just forget this number, it doesn't really matter. This F12 and F21 is just telling you the number of forces that are present in the given diagram. And if you come to this diagram, you see that we have F23, which is the force here, and F13, which is F23, which is the force here, and F13, which is the force here. Now we are going to apply this law. Now using it, this F12 is this one representing this one, which is equal to this KE Q1 Q2 over Q2 over R square R vector R minus, as if you can see from the formula, we have minus F21. So this is going to be minus KE Q1 Q2 all over R square vector R23. This one should be vector R13. So this is just representing this KE Q1 Q2 over R square vector R13 is the first one, while this one is the second one. I hope that is clear. So if you are adding it up, remember we say is the sum. So if you are adding it up, you are going to have equal to, this is going to be equal to KE. What is KE? That is the constant. KE open bracket, you're going to have 1 times 1 all over 0.5 square minus 1 times 1 all over 1.5 square. So I know the question is, where do we have 1 times 1 and 0.5 square? And don't forget to close this bracket, very important. All right, so the question is, where do we get these numerals from? But if you can trace back to our diagram below, above, you see that we have 0.5, we have 1.5. That's why we have 0.5 here, 1. Neglect the zeros. Don't this before somebody will be saying is 0.50. Just forget about this zero. Forget about this zero. And now the reason why we have 1 times 1 is because this 2 is placed into the middle. So this charge is having 1. This charge is having 1. If you put them together, you have 2. So 1 times 1 is 1. 1 times 1 is still 1. That's why we have things like this, which I believe is clear. So if you have this thing like this, what are you going to do next? What are you going to do next? What is the constant? What is the value of the constant? What is the value of the constant Ke? Which we already know we are going to have minus 8.9876 times 10 raised the power of what? Okay, you know it, raised the power of 9 times, if you do this minus 8 point something that we write here is just that Ke. Remember, the Ke is the constant, so this whole thing is just the Ke. So multiplied by this bracket, if you do the arithmetic very well in this bracket, you're going to have 3.56. This bracket is 3.56, while this Ke is 8.9876 times 10 raised to the power of 9, which I hope is clear. So okay, so adding it, because we say is the vector sum of our forces representation. So if you add this to this, you are going to have what? If you punch your calculator very well, I believe you are going to have 3.2 times 10 raised to the power of what? Raised to the power of 10. And it is measured in what? In Newton. Why is it measured in Newton? Because it is a force, and this becomes the answer. I believe you find this video interesting. Thank you very much for watching and paying attention to listen. I am your Hemba Sunen Vitalis, the class rep, Mechanical Engineering 200 level. Thank you for watching.